a new measurement of the Hubble constant using fast radio bursts. Again, Hubble constant is expansion rate. Fast radio bursts are these interesting observational things where you get a very short burst of radio frequency electromagnetic radiation from a particular part of the sky. And this is useful for measuring the expansion rate. Again, remember, you always have this problem with measuring the expansion rate, and that you don't actually know how far away something is. You can measure how fast it's receding really normally quite easily by measuring its Doppler effect. That just the same way when a car is driving past you, you hear this Doppler effect. That when it's coming towards you, you hear a "ee," and then as it goes past, it goes "ee." Just like that with light, you get a change in the frequency, and so you can measure how fast something's moving away from you by this Doppler shift. But you don't know how far away it is because it could be dimmer intrinsically, or it could just be further away. So you always need some sort of clever way of measuring that distance before you can measure the expansion rate. So fast radio bursts become useful for measuring the expansion rate because there's this thing called a dispersion measure. As the light from the radio burst travels through the universe, it interacts with free electrons in the universe and it gets dispersed. That different frequencies inside this radio burst. So they're all radio frequencies, but they have different radio frequencies will get dispersed more or less. I forget which way it goes. I think the higher frequencies get less dispersed. So they travel slightly faster than the lower frequencies through this medium. But that means that you can look at a galaxy where a fast radio burst is coming from and be, okay, I know how far away that is because I know how much the radio burst got dispersed, how much it got widened. And the crucial difficulty here is isolating which galaxy a fast radio burst came from. And once you've done that, you can measure this redshift, you can measure this Doppler effect, you can see how fast something's moving apart. And I think these guys had about 7 fast radio bursts that could be isolated to a galaxy, and therefore they got this first measurement. It wasn't a very precise measurement, had a very large error bar, so it's actually consistent either with the more precise SHOES supernovae and Cepheid measurement or with the Planck prediction. But it was a first step that in the eventual future, once many different fast radio bursts have been localized, we'll be able to more accurately measure it. And in fact, I remember if you go to today's papers on the archive, there is in fact an 8% determination of the Hubble constant from localized fast radio bursts. So even in the time between whenever this paper was published some number of months ago, April 2104, so 2021, 4th month, and now there've already been a better measurement of the Hubble constant from fast radio bursts. So I imagine if we were doing this again in a few months, that this paper might be higher up the hierarchy.